In this video, we're going to look at the sum of a geometric series. Let's start off with the basic geometric series. We're going to have a first term of 3, so a is 3, and a ratio r of 2. So I've just chosen those values. Let's look now at generating the first few terms of this geometric series. The first term is going to be 3. We now need to add to that 3 times by the ratio of 2, which is going to give me 6. We then need to multiply by the ratio again, which is going to give me 12. We multiply by the ratio again, which is going to give me 24. We multiply by the ratio again, which will give me 48. And then, of course, we can continue this up to now the nth term. And the nth term will simply be 3 times by 2 to the power of n minus 1. If we wanted to write out an expression for each of these, this one is a, then we add to it ar, we add ar squared, we add ar cubed, we add ar to the fourth, right the way up, and of course our nth term is ar to the n minus 1, as we've seen in previous videos. We could of course do this manually, but there must be a more efficient way of summing the first n terms of a geometric series. In the video, we're going to start off by looking at the formula and applying it to some basic questions, and then later on we're going to look at the proof. So let's look at the formula we use. We say the sum of n terms, s sub n, of a geometric series with first term a, common ratio r, is given as a multiplied by 1 minus r to the power of n over 1 minus r. So s sub n, subscript, we've got the n there, a 1 minus r to the n over 1 minus r. Later on we're going to need to show how we prove this, but for now we're simply going to look at applying it. An alternative way of writing it is the sum of n terms is going to be a, then we have r to the n minus 1 over r minus 1. Often people prefer to use this if the ratio is greater than 1 to avoid any negative values. It's a calculator unit, so I'm just going to use this one right here, as that's the one we're going to prove. They give exactly the same answer. So let's go ahead and look at applying this to some basic questions and finding the sum of a geometric series. Whenever we start a question with a geometric series, I suggest you write down the side of the page a, r, s and n. This is particularly helpful if we have wordy questions where we need to decipher what values we have. We'll always have 3 of these and we need to find the fourth. First term, ratio, sum, and then the number. So let's go ahead and look at some basic questions. In question 10, we need to find the sum of the first 8 terms for each geometric series. So we'll use the sum of n terms is equal to a, we'll have 1 minus r to the n over 1 minus r. In terms of the a, r, s and n for the first one, well, we've got it here, so it wouldn't really be necessary. I think getting into a habit is quite good though, just for when we get to the wordy questions. So on the first one, first term, a is 4, common ratio 0.1, we need to find the sum and we're given that n is equal to 8. So what we can say then is that the sum of 8 terms, first 8 terms, I'm just substituting in here, is going to be the first term multiplied by 1 minus the ratio, which is 0.1, to the power of 8, and then we divide by 1 minus the ratio, which is 0.1. If you want, you can do some simplifying of this before you put it in the calculator. Alternatively, it can just go straight in. So what we're going to have then is 4, then we'll have 1 minus 0.1 to the power of 8, and we need to divide this by 1 minus 0.1, which I'm just going to put as 0.9. That's going to give me 4.444, and then we have now 4444. So I'm just going to write this, and we'll just have 4.444, and I'll just write this as to 3dp. So to 3dp. We're not given a level of accuracy in this particular question. In an exam, generally speaking, you would be, or you would find an appropriate degree of accuracy. Okay, let's look at the next one. On the next one, A, R, S and N. Again, really quite clear from the question, but a good habit to get into. So this time, A, the first term is 0.4, the ratio is -3, and we're looking for the sum given N is 8. So we say the sum of the first 8 terms is going to be the first term, which is 0.4. Then we'll have 1 minus, and then we've got -3, which we need to raise to the power of 8, and divide this by 1 minus now the -3. So all I've done is simply substituted in. A is 0.4, R is -3, N is 8, and we've put it in like so. So in the calculator, we've got now 0.4, we've got 1, we subtract from that now -3, which we need to raise to the power of 8. We divide this now by 1 minus the -3, which is going to give me 4, and that gives me -656. So -656. So you might say, well, why don't you just write out the terms? With the first term, we can see a first term is 0.4. Then we would need to multiply by -3, which is going to give -1.2. Then we would get positive 3.6, -10.8, positive 32.4, -97.2, that looks like -97.2. Now if you look, I've only got the first 6 terms here. You can see that doing this, and often students who forget or don't have the formula to hand often start doing this. You can see though, if the numbers are really messy in terms of a ratio and a first term, then clearly it's far more effective to do it this way. But and this is the exact reason that we have the formula. So let's look at the last one. We've got now A, R, S and N to write out. A is going to be -5. The ratio is going to be -0.3. We're looking for the sum, and now we've got a value of N, which is 8. The advantage also of using this is that if we don't need to find S and we need to find, for example, N or A, then we can just rearrange the formula. So the sum of the first 8 terms is the first term, -5. We'll have 1 minus -0.3, which we need to raise to the 8th power, over 1 minus now -0.3. So again, straight through this formula, put the values in, and then find the answer. So what we've got then on this one, we've got now the -5. So we've got -5, we've got now 1, and we're going to do now, so it's 1 minus now the -0.3 to the power of 8. Let's put that on like so. And then we're going to do now 1 subtract -0.3, which is just going to give me 1.3. So -3.846. So let's write this in. So -3.846. And again, that's just to 3dp. I've just given it that level of accuracy. If I wanted, I could have gone the other way round with this. So what I could have done instead is -5. And then I could have done now the ratio, which is -0.3 to the power of 8 minus 1 over the ratio minus 1, which is the -0.3, and then subtract 1. We would get exactly the same answer. That is just the formula written the other way around, and as you can see, same answer. Okay, so let's just change things around. What we're going to do here is just use the formula. So let's just go back to the sum of n terms. The sum of n terms is going to be A, then we have 1 minus r to the n over 1 minus r. What we might be given is that we've got a ratio. Let's just write this on. Ratio is 2. We might say now the sum of 10 terms is going to be, let's go for 5115. And what we might need to do is find first term. So this is the advantage again. If we're told the ratio is 2 and we're told the sum of the first 10 terms is 5, what have we got, 511.5, we need to find the first term. Well, let's just go ahead and define what we're after. A, R, S and N. So we want this value. That's A. That's what we're looking for. We're looking for the first term. We're told the ratio is 2. We're told now the sum of the first 10 terms, so N is 10, is 511.5. And what we need to do is find now the value of A. So all I do is substitute in. So 511.5 is equal now to A, which we're trying to find, 1 minus now the ratio, which is 2 to the power of 10, and that would now be over 1 minus the ratio, which is going to now be 1 minus 2. So all I need to do is a bit of rearranging. So what I could do is multiply both sides by essentially -1. So negative 511.5 divided by 1 minus 2 to the power of 10 is going to give me A. So all I've done is taken this quantity here, which is -1, multiplied and then divided. Or you could say that you're just going to multiply by the reciprocal of this fraction. So if we did that, then what we can do is find A. Obviously, manually summing that is not going to allow me to do it. So we can see another advantage to this. So 1 minus 2 to the 10. So this is going to give us the value of A, and A is 1/2. So A is equal to 1/2. You might think, why am I trying the hard sell of why we should use this? As stated, often students do either forget it, don't have it to hand, or can't be bothered to learn it, and simply want to write out the terms down the side of a page and add them. These are only going to be worth a couple of marks in an exam, as it's simply plugging into a formula. Okay, let's look at question 11. We're asked to find the sum of the first 10 terms for each geometric series. So let's look at the first one. We've got 2 plus 6 plus 18 plus 54 plus so on and so forth. So A, R, S and N. If we look, A is going to be 2. We know that N is going to be 10. We want the sum. We need the ratio. We're told it's geometric, so I don't have to check. We got 2, 6, 18. Well, 6 divided by 2 is going to give me 3, and that's the ratio. So using the sum of n terms is equal to A, then 1 minus r to the n over 1 minus r. Again, it's just now plugging the values in. It might seem trivial, but writing this out for some students allows them to find that third piece of information. Remember, you're going to have 3 pieces of information and you need to find the fourth. The only time you won't have 3 knowns is if you have to set up simultaneous equations. But generally speaking, you'll have 3 and you'll find the fourth. So we've been finding S. Yeah, on the last example I just did, we found A. So let's go ahead and find the sum. The sum of 10 terms, S sub 10, sub as its subscript, is the first term. Then we'll have 1 minus r, which is going to be 3 to the power of 10, over 1 minus r, which is going to give us now 1 minus 3. Can do a lot of simplifying with this one. So 1 minus 3 is -2. So that's -2. Now 2 over -2, which is -1. So if you wanted to really simplify this, you could just write it as 3 to the 10 minus 1. It's going to give us something near 60,000, but we'll do it anyway. So 3 to the, what is it going to be? 3 to the 10 minus 3 to the 10. Just let's put that in correctly. Need to come out of there, don't we? Minus 1. 59,048. So 59,048. Of course, I've just done that because it's nice and straightforward to do. If you wanted to do it on a calculator, all we're going to have then is 2, and we've got now 1 minus 3 to the power of 10, and that is going to be divided now by 1 minus the 3, and that gives us that value right here. In the same way, you could have done 2 lots of 3 to the 10 minus 1 over 3 minus 1. Same value. Let's have a look at the next one. So this one, we'll collect the information. A, R, S and N. A is the first term. Then we've got the ratio to find. The sum we're looking for, and N, the number. So first term is 5. we know that there are 10 terms. The ratio is going to be 10 over 5, which is 2, and that holds throughout, so that's 2. So again, straight through, the sum of 10 terms is going to be equal to the first term, which is 5, 1 minus the ratio, 2 to the power of 10, over 1 minus the ratio of 2. So let's go ahead and see what this is. So hopefully by now you should be fairly fluent with this. It's simply identifying which values are which and substituting into a formula. Not much different to substituting into a quadratic equation where you've got A, B and C. So 5115, so let's write that in, 5,115. Let's do the last one. On this one, let's look A, R, S and N. We've got now the first term, which is going to be 8. We need to be careful here, so we've got now 8 minus 2 plus 0.5 minus 0.125. Well, if we did 2 over 8, that's a quarter, so therefore our ratio will be negative. A half over 2 is a quarter, but again, one's negative, one's positive, so the ratio is negative 1/4. 10 is going to be n, and we can say now the sum of the first 10 terms is now first term, 8, 1 minus the ratio, which is negative 1/4, to the power now of 10, so let's put that on, and that's over 1 minus now the negative 1/4. So let's just plug that into a calculator. So we've got now the first term, which is 8, we've got 1 minus, and we could write this now as negative 0.25, entirely up to you, negative 0.25, and we need to raise that now to the power of 10. And then we're going to divide that now, that looks good, by 1, subtract now negative 0.25, so this is just going to be 1 add that 0.25, so 1.25, and that gives us 6.3999 and so on and so forth. So I'm just going to say this is going to be 6.40, and we'll do that to 3 significant figures. So 6.40, and that now is 3 significant figures. You'll be given the level of accuracy in the exam. I'm just going now to get an answer that is somewhere near accurate. So there we go. Some nice, straightforward, basic questions looking at using the geometric series summation. What we're now going to do is look at the proof. In question number 12, it says, show that the sum of the first n terms of a geometric series with first term a and common ratio r is s sub n is equal to a, 1 minus r to the n over 1 minus r. So all I'm going to do is write out the sum of n terms manually. The sum of n terms is going to give us the first term, a, the second term, ar, the third term, ar squared, ar cubed, plus dot, 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 so on and so forth, right up to that nth term of ar to the n minus 1. What I'm going to do is rewrite this now below, but multiply through by r, the common ratio. That's going to give me rsn. The first term is not going to be a this time, it will be a multiplied by r. All I'm doing is multiplying each term in the particular summation here. So the first term will be ar. I could of course write it here, I'm going to write it here as it's easier to see. Second term will be ar squared, ar cubed, then we'll have plus dot, 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 dot. The penultimate term this time will be ar to the n minus 1. And of course, if we multiply this now by r, this is going to be plus ar to the power of n. So, for example, at this stage, if n was going to be 7, this one would be 6, and of course this one would be 7. At this stage, we're simply going to subtract. We're going to do s sub n minus rs sub n. If we're subtracting on the left-hand side, we're subtracting on the right-hand side. The reason I've written it like so is that these terms are going to cancel if we subtract downwards. So all the terms that match when subtracting downwards will disappear. Therefore, what we can say is the following. We can say now the sum of n terms minus r multiplied by the sum of n terms. We're left with the a. All of these terms cancel, and then we simply subtract away the last term, which is ar to the power of n. Factoring on the left-hand side, s sub n is common, so we take s sub n out. That's going to leave me 1 minus r. On the right hand side, a is common. We factor that out, and that leaves us 1 minus r to the n. At this point, we simply go ahead and divide through. So we have the sum of n terms is a 1 minus r to the n over 1 minus r. And that is our proof. So if you're asked to show the sum of the first n terms of a geometric series with first term a and common ratio r is this, that's all you need to do. So there we go, basic introduction to geometric series summations. Over the next few videos, we're going to look at a range of different questions involving words, sigma notation, and generally more tricky concepts. But for now, as long as you can use and apply and also prove the formula, then you're in a good position to start.